Okay, I'll get a little reminder here since I'm not in class today on how we graph these rational functions. So I'm using my notes and I'm going to go through step by step to find all the features of this graph. You can always check your graph on Desmos after you do it, but it won't show you a very obvious hole. You have to like really zoom in to see the hole. It's because they're just not as good as we are. Okay, so starting with a problem like this one here, number 1, this is your assignment for today, so you're getting a freebie. Always the first thing we want to do is factor. So if I factor the numerator, that's going to be x plus 1, x minus 1, because those are perfect squares. And then on the denominator, what multiplies to -3 and adds to -2, well, that'll be x minus 3 and x plus 1. Okay, and just as we did previously, if you have factors that can cancel, we should. So these will cancel out. And so my brand new equation now is actually x minus 1 over x minus 3. Okay? So after we factor, the first thing we want to find are holes. If you had a factor that canceled, then you have a hole. So we did. So I take that factor and I set it equal to 0. And I find that the hole happens where x is -1. But a hole is kind of like a point that's supposed to be there, but it's not there. So we need to find the y value as well. So once I know that x is -1, we want to plug it into our equation to find the y value. So -1 minus 1 over -1 minus 3 will be -2 over -4. So positive half. So that's kind of where our hole is. I'm going to maybe find all this stuff and I'm going to plot points at the end. I might graph my asymptotes as we go because those can be helpful, but I'm going to plot points at the end. So second thing we want to do is we want to find our vertical asymptotes. So vertical asymptotes are what happens in the denominator, like what's left. So I have a vertical asymptote at x equals 3, because whatever's with x is always opposite. Next, we want to think about horizontal asymptotes. And with horizontal asymptotes, this can be the tricky one. So you have to check the degree or the exponent of the numerator and denominator. Okay, so if the numerator is larger, then we will synthetically divide and get a slanted asymptote. If the denominator is larger, then my horizontal asymptote is always 0. However, if they are the same, which in this case they are the same, then my horizontal asymptote happens when I divide their leading coefficients, so like the front numbers. And so both these front numbers are 1, and 1 divided by 1 is 1. Okay, let's put those asymptotes on there. So we're going to have a vertical at 3, a horizontal at 1, which kind of gives me my new quadrants. Some other pretty easy to find points are the x-intercepts. So the fourth thing I'm going to think about are my x-intercepts, because now I need some points because I'm not really sure which quadrants they're going to be in. The whole will tell me, but x-intercepts are also helpful and pretty easy to find. So the way that we find our x-intercepts is we think about whatever the numerator is. So whatever's with x is opposite. So I have an x-intercept at 1. So like 1, 0. So we could plot that. I can also think about where the hole is. So the hole is at -1, half. And so we plot that hole as like an open circle. And that's giving me a pretty good idea that I have a hyperbola branch happening right here, getting closer and closer to those asymptotes. Another easy point to find, and I'm like kind of running out of room in here, is my y-intercept. The y-intercept happens when I put 0 in for x's. So I basically just ignore x's, and I have a y-intercept at 1/3, or 0, 1/3, which also makes sense because this was at half, and this is at 0, and 1/3 is kind of in between that. So that's totally showing me that I do have a branch over here. So I can get that sketch going like this. And the thing is, if I have a branch over here, I'm going to have one opposite. And so like what you could do if you want to be real accurate over here is I could take something like 4 or 5 and plug it into my equation. So I don't know, let's just plug in 5. So if I plug in 5, we'll have 5 minus 1 over 5 minus 3. So 4 over 2. So then y is 2. So when I plugged in 5, I got y is 2 right here, which totally shows me that, in fact, it is up here like I expected it to be. And at this point, I'm just going to like follow the asymptotes. Okay, so hopefully we feel pretty good about that graph. But like I said, at the end, if we want to just double check with Desmos, we want to go to desmos.com. We want to click graphing calculator. And then when we type this in, make this big. I don't need that. We want to bring this up here. So we're going to type this in. The equation was y equals, I'm going to type in the full equation. Now, because your numerator and denominator have multiple numbers, I would use parentheses just to be safe. So like x squared minus 1 was on top, and then we're going to divide that by our x squared minus 2x minus 3 on bottom. So we totally get a very nice looking graph. And again, it does not show you your whole. I think even if I zoom in, let's move my face here. I don't know that it does even if you zoom in. Yeah, it's just no good. It just does not show us that whole, even though it is happening right there. So anyways, cute, good looking graph. We did a good job. There's that y-intercept, there's that x-intercept. When I plugged in 5, we got out 2. Love it. All right, good luck on the rest, guys.